Now that you've installed your Series P filter pack and you've determined the optimum pressure for your application, you're ready to do a concentration study. There are two very different methods for running a concentration study. Some applications will run a single pass mode using timers. Some applications will do a batch mode in which you simply concentrate the feed material in the feed tank as shown during L testing on this video. I'm going to do a brief description of both methods and then we'll demonstrate the single pass method on the actual machine. For instructions on how to run a batch mode concentration, simply refer to the concentration study in L mode. The only difference in P mode is the amount of surface area being used in the P filter pack. The operation of the unit will be the same. During single pass operation, the VSEP unit is fed with a continuous feed source. The recovery rate is manipulated via an automatic concentrate valve by adjusting timers that control this valve. For batch mode operation, a fixed volume of feed material is processed while one removes the permeate stream from the feed tank and gradually concentrates the feed material until the endpoint is reached. Again, for a full demonstration of how to run a batch concentration, please refer to the concentration study in the L mode testing covered in this video. Now let's demonstrate how to run the VSEP P mode testing in single pass. In order to run a concentration test in a single pass mode, the timers are used to manipulate the auto valve on the concentrate line. There are two timers, one for the open cycle of the valve and one for the closed cycle of the valve. By manipulating this valve, you'll be able to set the recovery rate desired. Before setting your timers and switching the VSEP to auto mode, you must first set the operating pressures of the VSEP under both conditions, valve open and valve closed. First, to make sure we have the optimum pressure when the auto valve is closed, Kira is going to manually close the concentrate valve slowly. As she does this, she's going to adjust the bypass to get the pressure back down to the optimum pressure that was previously selected. As she slowly closes the valve, the pressure will increase. Now she's going to open the bypass just enough to get the pressure back down to 200 psi, which is our optimum running pressure for this specific example. Now that we're back at 200 psi, at this point, she knows that when the concentrate valve is fully closed, the pressure is at our optimum. The second step is to open the concentrate valve slowly until the concentrate flow is between 2 and 3 GPM on the flow meter. We now have the pressure and flow set for the open valve position. Once you've set your optimum pressure for the closed valve conditions and your optimum flow for the open valve conditions, you're ready to adjust your timers. An ideal setting for startup is 0.1 minutes open and 0.9 minutes closed. This will be a good starting point for most applications. Now that you've got the timer set and the valve set, you're ready to put the system in auto mode. By turning the switch to auto mode, you'll notice the concentrate valve cycles according to the timer's set points. The pressure set point when the valve is closed is the bulk of the timed cycle and should be set to the optimum. If it is not, make the adjustment using the bypass valve. At this time, you're going to take your first data point reading. During single pass operation in P mode, it's important to get your permeate rate and your concentrate volumes during the valve open period. First, we'll take the permeate flow reading. It's important to take the permeate reading at the center point of your full timer. If your timer is approximately 1 minute, 30 seconds should be the midpoint of your reading. Record the data as milliliters per minute units. In order to collect the dump volume, you're going to use a graduated cylinder and collect the full volume when the concentrate valve opens, purging the system of the concentrated material. You will then take this volume and divide it by the total time cycle in minutes to get your concentrate flow rate in milliliters per minute units. By recording the permeate volume and the concentrate volume, you can use this equation to calculate the percent recovery of the systems. If you are below your percent recovery rate, you can adjust the timers to increase that recovery rate by increasing the close time. Larger close times will result to lower concentrate volumes and thus higher recovery rates. If you wish to have a lower recovery rate, do the exact opposite. Decrease your close time in order to have higher concentrate flow rates and lower recovery rates. A few notes that are necessary during this process. Your concentrate dump volume should always be between 600 and 1200 milliliters per dump cycle. If your dump volume is larger than 1200 milliliters per minute, adjust your open time to be slightly smaller so that less material is purged during each dump cycle. After running the system for approximately half an hour, make the adjustment to your new recovery set point based on your calculations. Always allow the system to run for approximately 30 minutes before making the next change to the timers.
Before turning off the system, make sure to flip the auto switch to open. This flushes out the filter pack. And then stop the machine and then switch the valve back to close. This keeps the system hydraulic.
Now that Kira has demonstrated the single-pass concentration study in P mode, let me talk about a couple of points that are important to remember. Once you've set the optimum recovery rate, run a long-term line out at that recovery rate. Please run the system as long as possible, collecting as much data as possible in order to ensure that enough data is available for system scale-up. After you've collected this data, send it to a NewLogic representative for analysis. If you need more help on running in pilot mode, consult the manual or contact your NewLogic representative.